Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy. And first of all, thank you so much for subscribing to the channel. It really helps a great deal. Thank you to those of you who have given videos a thumbs up or have shared them with others or have commented on a video. Again, very much appreciated. I love seeing your comments and your requests for videos. That's very helpful to me. So I hope to see you commenting below or in other videos. Now in this video, we're going to look at some 2-digit and 3-digit subtraction examples. And those of you who saw the last video I posted where we looked at addition examples, these numbers may look familiar. As I said in that video, I just used my random number generator on my phone to get some 2-digit numbers and 3-digit numbers, and that's what I've used. Here, I just rearranged the numbers to make them subtraction problems instead of addition problems, but that's why these should look familiar. Now, in these videos, I keep talking about 5 strands of math proficiency, and I'll try to leave the link in the description below so you can see that video or get additional information. There's one just in general on the 5 strands and one in particular on procedural fluency. But the one thing to remember with procedural fluency, it's about efficiency and flexibility. It's not that we're going to teach your child a whole bunch of strategies and then they pick the one that they are most comfortable with to get the answer. See, it's not about just an answer getting technique that they can use as opposed to using a calculator. It's about them feeling comfortable, being playful, and understanding place value and number sense so that they are really flexible in how they work with numbers. And they look at certain problems and think, oh, I could do that one this way. I could do it this way. So it's a playfulness, and it really comes with a strong number sense. In this case, though, we're going to look at these 4 problems. Notice how I've written one horizontally, one vertically, and then 2 of them are a little askew, and that might feel uncomfortable. But one thing that's important for your child to understand, whether they're adding or subtracting, they're removing same size units. And you might hear, we used to talk about borrowing when I was in school. It's not borrowing as much as thinking of equivalent ways to make the same number. For example, I could have 4 10s and 8 1s to make 48, but I could also use 3 10s and 18 1s to make 48. Think of money. So there are lots of ways to make the same value using currencies, 1s, 5s, 10s, 20s. Same idea with number. We want your child to understand there's lots of ways to make the same quantity using 1s, 10s, hundreds, thousands, and on up. So if we need some more ones, we have ways to make those, okay? So we can teach your child a procedure. That's one way, and that can be very effective. It's not that that's a bad thing or a good thing. It's that that's one technique. Another is getting them, again, to be playful and so comfortable they work between different approaches for number and can understand that subtraction is meaning removal, or it's also meaning how far apart, missing addend, think addition. So if you would, I suggest pausing this video, trying to come up with how many different ways you could subtract these problems, these numbers and these problems. Pause the video, as I said, come up with that. When you're through, come back, and I'll share a few ways to look at these different problems. And just as a heads up, I'm going to start with the 85 minus 82 problem. That will be the most straightforward, I think, okay? See you in a few if you pause. Now, if you did pause, welcome back. As I said, we're going to start with this problem. And I hope you'll pay attention not just to what I'm writing here, but the language I'm using. What we're trying to do is remove 82 from 85. Now, there's lots of ways I can think about it. I could think about having a quantity that I'm removing 82 from. And you may see some of your children drawing what would be base 10 representations. Now, for me, I have them draw 10s using these lines, using those what look like tally marks really, but the sticks. And we're going to start with 85. Okay, we draw ones with dots. For me, that's worked the best because with base 10 blocks, some of your children may draw a big square for the hundreds, a thin rectangle, tall rectangle for the tens, and little squares for the ones. But I find as children get going quickly, all of those units start to look the same. So for me, I have them draw the square for the hundred, these rods for the tens, and little dots for the ones, and that's worked well. Now think about what's going to happen when I remove 82 of these. It's pretty straightforward, right? The 8 tens all go away, and 2 of these go away. And it doesn't matter which 2, but I can see I'm going to be left with 3 ones. I remove 8 tens from 8 tens. I won't have any left. 2 ones from 5 ones. See, I had enough tens and I had enough ones that I could just remove what I needed. I didn't need to think of these numbers in a different way. Now, another option is to think in terms of an open number line. And there are videos with open number lines. And so the idea is if one end is 82 and the other end is 85, how far apart are these numbers? And essentially, I can just do jumps to get to the other end, right? I have one gets me to 83, to 84, to 85, right? I can just do jumps of one, and I learn that these numbers are 3 units apart. Now, where this typically, right, makes sense, I'm thinking of subtraction as removing here. I remove, I end up with 3. Here, I'm almost thinking of how many more than 82 is 85, or how many fewer than 85 is 82. See, there's some more flexibility for your children. Understanding the way to work between. But the way I did this, I was coming up with the missing add-in. How many more than 82 is 85? And that's an important little nuance to notice. When we subtract, we don't always go left. When we're looking at the distance between the numbers, I could go right. Okay? So just a couple of ways to handle that problem. Now, let's look at the 71 minus 44, sorry. Now, I'm going to start with the number line. I'm going to start with the one where I try to find out how many more than 44 is 71. That's how we ended the last problem, so let's start this one. Essentially, I have an open number line. I'm trying to find out how far apart 44 and 77 are. Okay? Now, think about how you might do it. And I'll apologize up front for my drawing. I'm sure I won't get it to scale. I might try, but I don't know how well I'll do. But see, to me, I want to get to the next decade. So I would tend to make a jump of 6 to get me started. Now, just as an aside, this is also a way we want your child to be able to count back change, right? You start with what a person gives you, and then you start giving currency back to get them to the next whole dollar or multiple of a dollar, right? To get to 1, to 5, to 10, to 20. And there's again a flexibility, but it's a counting on strategy. Okay, so I can do this where we count on 6 to get me to 50. I can count on 10 to get me to 60. I could count on 10 to get me to 70. And then I do another jump of 7. Now, there's all varieties of ways that I could do this, right? I happened to get to the next decade and then did jumps of 10. That was comfortable. I add all of these up, these jumps up, and I end up with 20. Now, I did 77. I changed the problem to 44 plus what equals 77. Were you yelling at the camera just then? In that case, it would be 33. Let's go back and do the one for the problem I had. Goodness me. to 71. Same idea, but I'm going to do the jumps a little differently this time since you've already seen the one. I could do the 6 to get me to the 50, but instead of jumping by tens now, some of your children may just do a jump of 20. They'll combine those two into one jump, and then they'll do the jump of 1. Okay, so when I'm looking at how many more than 44 is 71, well, I can see it's 27 more. Now, there are other ways, and there's a lot of variation in what we might see with your children here. Some kids will just automatically do a jump to get them close to 71. So they might do that jump of 20 up front. And then they may do a jump of 6 and one more. So you may still see the same jumps of what I just did, right? But just in a different order. You'll see all kinds of variations. What we want to work with your child on doing is moving from jumps of 1. Now, some of you say, oh, my child just knew it was 27, and sometimes they're doing in their head. But as we're using these strategies, and I hope you saw if you watched the addition strategy one, we're building the foundation for algebraic properties at the same time. We're also here building a foundation for what they can use when they get to negative integer subtraction. So both of these, it's important to understand both a distance model, and I could also have done a removal model, a different way of thinking about this. And let's just show you what I mean by that. Another way to think of subtraction is as removal. And I'll try to stick with 71 this time so you don't have to yell at the screen. So here's 71. I want to remove 44. Now see, I need to understand I remove tens from tens. So I can remove 4 tens from the 71. That's easy enough. And it doesn't matter which 4. I could have removed 4 from this side. I could have skipped around and done it. Okay. But I can remove the 4 tens. And then I somehow have to remove 4 ones. So many of us learned a trading in, like trade in a 10 for 10 ones, and then you remove it. An equivalent way to think about it. Now, I think about it in terms of paying for something at the store. I've never said to a cashier, oh, I don't have enough pennies. Can you trade me a dollar or a dime for 10 pennies, then I'll pay you? See, no, we tend to just give back change, right? We make change. We think almost of this 10 could be 6 and 4. I remove the 4 and I'm still left with 6, that change coming back. Now see, when you're through, I still have 27. And there's lots of ways I could have removed. You'll see some kids who start with the same drawing. And I'm thinking of this type of drawing as a second grade, right? This is a problem for second graders they can do if we've done enough of that early number sense work with them. To remove 44 here, some children, I'm going to remove this 40 this time, and they'll remove the 1 and they know, oh, I still need to remove 3 more. And they'll cut one of the 10s into 3 and 7. Now, as with the others, right? No matter how I do it, I better end up with the same answer. Now, in this case, essentially what they did was they thought of 44 as 40 and 1 and 3 more. Now, notice the way I've written this, the way I have to do this, or I thought about I removed 40, then I removed 1, then I removed 3 more. This shows me a distributive property link. The notation is a way that we can provide your children who are quite curious about math, interested, enjoy it. That helps us also challenge them a bit more with a specific notation. Okay. Now, I want to show you one other way to think about this. It's a strategy I haven't shared in other videos, I don't think, but it's a way to think about equivalent difference. And I just want to show you this. We're just going to use a ruler. Let's see if I can back off a little for you. I know you won't necessarily be able to see the numbers. Here's 0, 1, 2, 3, 4, 5. Many of us learned a way to measure by lining up. Okay. And I'm actually going to do this where we'll make this a 2-inch strip. Let's see if I can fold it to get it to 2 inches here. Closer. The important thing to understand about this is I could measure 2 inches there, but I could also slide it anywhere up or down. I could put it between 2.5 and 4.5. Okay. It's understanding that that distance, that open number line distance, I can keep it the same by sliding up or down. So let's just think about, I'm going to draw a number line here. Notice how I'm using the signs that show it can go off in either direction. Let's say I have 71 at one end of what I'm measuring and 44 at the other. Now, I could take that imaginary strip that's right there, and do you understand? I could slide it down to 70, and this end down to 43. So this is equivalent to 70, the distance between 70 and 43. I could slide it down because that's not any easier to me. One more, and that's the same as the difference between 69 and 42. Now, in terms of strategies we used, this requires regrouping, no regrouping. So if I can find this difference, it's going to be the same as this. So I can think of it in different ways. How far apart are 42 and 69? I could remove 40 from 60. That's 22 from 9. That's 7. I'm doing it again in my head. I can get it to a problem I can do mentally instead of one that I feel I have to do paper and pencil with. Now, before we leave it, I'll show you one more strategy. And this is one that will look familiar to many of us who were taught a regrouping algorithm to use, right? I don't have enough ones. Now, to me, instead of borrowing or regrouping kind of thing, I think of what's an equivalent way I could make 71 that gives me more ones. Well, how could I make it? Remember in our one picture here, I made 71 with 7 tens and 1 1. But what's another way I could have made it? I could have made it with 6 tens and 11 ones, an equivalent way. Now, you see, just by using that language, it's not a procedure I'm trying to remember, it's understanding the number sense, the equivalency. Now, 4 ones from 11 ones, 7 ones, 4 tens from 6 tens, 2. Same answer every time, just showing you a variety of ways and that flexibility for how I can work with these. Now, let's look at some of those 3-digit. And maybe you want to go back now and think about what's an alternative way that I could solve some of these 3-digit problems now that we've looked at some other strategies. Now, this one was written a little askew. It won't matter. I'm looking at numbers as whole. Now notice I can just use that same strategy I just did, right? So that's one option. I could slide this. Instead of sliding it down, I could slide it up. So 248, remove the 199, the distance between those, the difference of those is going to be the same as 249 and 200. This one I can do without paper and pencil. This one I need paper and pencil, right? So what will my answer be? 49. Could I do the open number line? Start at 199, go up to 248 and think, how many more than 199 is 248? Now, me, I'd make that jump of 1 to get me to 200. And then I probably would make the whole jump to 48. That 1 and the 48 would go into that blank, that missing addend, still end up with 49. So that's another way of dealing with it. We showed another one where I had two hundreds, 48. Now, do you notice even my drawing here, I try to organize it in a way I don't have to keep redrawing it. Okay, so I'm starting with 248. I'm thinking in terms of removal. Now, you can remove a lot of ways. You could remove the 100, right? So this is the problem we're working on. I could remove the 100 and then the 90 and then the 9. Okay. But for me, I'm going to remove the 100, and I know 99 is the same as 100 plus 1. So if I just break it up that way, I'm left with a 1. I still end up with 49 as my answer. But as I said, I could do removal a lot of other ways. Here's my 48. And by the way, I don't have to do them as 100 tens and ones with drawings. I could have organized this any way I wanted. But let me go back to the other problem where I said I could remove the 100. I could remove 90. So I could cut this thinking of this as 90 and 10. Okay. And then I don't have 9 ones. Maybe I cut this as 9 and 1. I'm still going to end up with 49. But for me, see, once I'm playful and understand, knowing that it's equivalent to 249 minus 200 makes that a very efficient strategy. If I'm going to rewrite this, it gives me a strategy that always works, but it's not necessarily the most efficient. And in this case, I need to think of 248, what's an equivalent way I could do it that gives me both more tens and more ones. Now see, here was my starting 248. I'm going to need more tens and more ones. Well, what's a way I can think of that? Well, I could have just 100. I could end up with 13 tens, and I could end up with 18 ones. Right? 100, 248. And there are ways we do equivalency charts, and there are videos about that to help your child. But this is, again, looks probably more familiar for many of us. 18 ones minus 9 ones, remove 9 ones, leaves me with 9 ones. 13 tens, remove 9 tens, leaves me with 4 tens. It's equivalency. Okay? So that gives you that one. I'm just going to turn this over. And the last problem, 876 remove 795. Whoop. I'm wanting to make new problems each time, aren't I? 795. Now, one of the strategies we haven't talked about yet is around and adjust. And again, other videos will show this. But see, immediately I think, oh, that's really close to 800. And that would be really easy to remove here. So if I took 876, remove 800, well, I've removed 5 too many. So I can remove the 800 and then I better give 5 back. It's around and adjust idea, right? So if I remove 800, 876 minus 800 gives me the 76. That's easy. Then I have to add back to the 76 the 5. Now, do you notice how I've rewritten this as a new equation? If I say plus 5 here, this is no longer equal. And I need to know that add equality sign isn't what comes next to the answer, but is a balance. So I'm going to write a new equation to show that final answer. Now, I could have written what I did here. Now, this would equal 76 plus 5. That's mathematically correct also, right? Because I'm including the plus 5 here. If I'm going to do it in steps, separate equations. Okay? Now, you can always go through, draw additional, I could have drawn 800. I could have drawn the 70. But eventually, we're wanting your child to picture these while they're actually working with the symbols, working with the other representations. With that 876, as I said, I can remove 700, and then I can cut this 100 into 90, 5, and 5. That's how I would probably do it if I'm working with the picture. Well, I get rid of the 95. See, what did I do? I essentially showed a round and adjust. Get rid of 100 and give 5 back. And when I give the 5 back, right, that's how I'm ending up with my 11, my 81. Okay, so I had to cross this out too to put it here. So, flexibility is what the name of the game is. Getting your child comfortable with quantity and number and representations enough that they are playful. They can come at it from a lot of angles, I guess you'd say, throw geometry in there. But they can come at it a lot of different ways. And then they're comfortable enough to know, well, I could do it this, I could do it this, I could do it this. This will probably be the one I can do mentally, like round and adjust, remove 800, give 5 back. It's that type of comfort that gives us procedural fluency. Okay, so I hope that helped. Please, if so, give it a thumbs up, share with others. Again, consider subscribing to the channel if you haven't already. It really does help. I really do appreciate it, and I look forward to seeing you in future videos. Thanks so much for watching.